So welcome back, everybody. So now that we've spent time on two things, mainly on using SQL from a host language, Python, PHP, and so on, and transactions, meaning when you have multiple queries and you want some guarantees as if you were the only one using the database. Now, what we are going to look at is how to improve the performance of your queries when you use a system like PostgreSQL, and how to also optimize your queries, like for productivity. So this is why it's called views and indices. So we'll look at views and then we'll look at the indices. So here's a table that I'm going to use as a sample. It has 3 columns: author, title, and year, of type, so a string, and then an int. Varchar is a string. And then you have these values in there, right? Where I have authors that wrote papers in specific years. Now, we've studied SQL, so now that should have no secrets for you anymore. If I say select star from publications where author is Albert Einstein, that's called in the relational algebra what is that called? Yes, a selection, exactly. And what I get is a subset of the rows, only those that have Albert Einstein in here. If I say Mariam Mirzakhani, then I get the subset that correspond to Mariam Mirzakhani. Now, what is this? This is called a projection, exactly. So now what I do is that I project to just 2 columns. The two of them together, projection and selection. So this is Albert Einstein, but just the titles and years. That's a grouping query, an aggregating query, you see. I told you always pay attention that when you have the grouping key in here, always put it also in the select, and everything else you have to aggregate. So here you aggregate the count of titles. Now we see we have 3 authors, Einstein, Mirzakhani, and Turing, with 7, 2, and 2 paper counts, right? That should be easy now, right? You've seen it so many times and done so many exercises that this is easy. You can order also. So here we order by year, right? Nicely ordered. So you saw that by now PostgreSQL basically uses a bag of record semantics, meaning that as long as you don't use order by, it's just a bit in a random order. And if you use order by, then it switches to lists of rows semantics, and then the order actually matters. Okay, you remember the pagination, limit 3, offset 2. So what are the positions of the records that this is going to give me? Yes? 3, 4, and 5, exactly. This is 3, 4, and 5. Limit of 3 means you return 3, and offsets 2 means you skip the first 2. So 3, 4, and 5. Yep. All right. Which brings us to views. Maybe this is where we're going to have to stop for the break. But basically, if you look at these queries here, imagine you're outputting all of these queries. Do you see anything in here that is kind of not very optimal? Does anybody notice something? Imagine in your Jupyter notebook, these are the queries you give in there. Do you notice anything? Yes? Yes. So this is always the same. Absolutely. This is inefficient. Not that it would be a problem for performance, but it's a problem for your productivity because you keep writing the same time all over. So after the break, I'll tell you how we can actually improve that with views. So see you in 15 minutes.